as we continue on, we just wrapped up talking about experimental studies or controlled experiments. Next, we'll talk about observational studies. So in contrast to that experimental study and the observational study, we just ask participants about what's going on. We don't have the ability to indicate a cause and effect relationship with an observational study, but instead we would say there's a link or an association between those variables. So once again, in that observational study, your participants are not given a treatment. They're just surveyed about their current or past habits or activities. We just ask a question. Nothing from the normal routine is changed. Going back to our coffee example and saying, does it affect sleep? In the experimental study, I had different groups drinking different amounts of coffee, and then placebo group and all kinds of things there. But in an observational study, I would just have my random sample, and I could ask on average, how many cups of coffee do you drink each day? And on average, how many hours of sleep do you get each night? And see, is there a relationship between the amount of coffee a person is drinking and how much sleep people are getting each night? Now, let's say the data shows that people who drink more than 5 cups of coffee each day tend to sleep less than 6 hours of each night. I cannot conclude that coffee is the cause of this because of a confounding variable. So a confounding variable is something we need to keep in mind with our observational studies. They're also known as lurking variables. These are additional variables that are not studied, that we didn't ask about, that can affect the other variables that we did ask about. So what could be a confounding variable in the coffee sleep study examined above? Well, if you think about it, there are a couple of things that could affect both your coffee consumption and how much you sleep each night. It could be your work schedule. If you have a work schedule where you have to go in at 10 p.m., you get off at 6 a.m., then you have to go home, take kids to school, go to class, do all these other errands, that might cut into how much you get to sleep. And as well, it might increase the amount of coffee you drink to try and stay awake as well. Another confounding variable could be your family life. People with small children, newborn babies, tend to not sleep very much at night, and they tend to drink a lot of coffee to stay awake in the day. So that could be a confounding variable that's having an impact on both of those. So that's why we can't say that coffee is the cause of those sleeping patterns. There could be a lurking variable out there that has an effect on both. As well, we need to always keep the idea of variation in mind. There's always going to be a variation in a set of data. So if you happen to buy a cup of coffee at a store, it's supposed to be 16 ounces. You won't always get an exact 16 ounces. Odds are you're going to be a little above that, a little below. Maybe it's 15.8 ounces, maybe 16.3 ounces. This is variation from data piece to data piece. As well, because we're using samples to try and estimate what's going on with the population, getting these statistics to estimate our parameters, we also need to keep in mind the idea of sampling variation. 2 or more random samples of similar characteristics probably won't produce the exact same results. For example, I'm on campus today, it's a Thursday. I could go out and randomly select 50 students across campus and ask them their GPA. I can find the average GPA, maybe it's a 3.1. If I do the same thing tomorrow, go out and randomly select 50 students, I'm probably going to get a different set of 50 students. And when I average their GPAs, I'm probably not going to get the exact same average again. So we have to keep sampling variation in mind as well. And we'll see slight changes from sample to sample. The size of the sample is important. The samples we've looked at so far have been fairly small, only a few hundred or so. In polling samples that you see in the news, usually you'll see somewhere between 1,200 and 1,500 observations. Those are considered large enough to get enough results to talk about a very large population. As we progress through the course, we'll talk about what a minimum sample size would be depending on the test that we're running. As well, keep in mind that very large samples may be biased. For example, call-in surveys are biased because if you see a number show up on your phone that you don't recognize, a lot of people would ignore that phone, but there's a certain group of people that would answer the phone every time and would be glad to share their results. And so that could skew results toward those people who prefer to answer their phone and give their opinions. As we discussed earlier, it's hard to get a large sample size to get enough people to participate because you have non-response bias, people not wanting to participate in your survey, and we can see some biased results from there.